Right, so once again, our lesson is being recorded. So I've instructed Zoom to record our discussion. Right, so we write down the equations of the asymptotes of the function. We note first that the function f is 4 divided by x minus 3 plus 2. So we have the vertical asymptote. Right, so the vertical asymptote is given by when the denominator is equal to 0. We take the denominator and equate it to 0, from which we're able to achieve that x equals 3. Now, the next thing we shall actually be able to do is to look at the horizontal asymptote. So the horizontal asymptote. Right, what is the horizontal asymptote? So the horizontal asymptote is y. Is y equals the constant, y equals 2. Right, so we're going to be looking at 5.2. Now determine the x-intercept. Determine the x-intercept of f. Right, so a couple of things become very important. X-intercept. How do you get the x-intercept? So to get the x-intercept, you actually let y be equal to 0. And if you do that, you'll have that the function itself is f of x, which equals 4 over x minus 3 plus 2. When y is 0, you have 4 divided by x minus 3 plus 2. Right, from this, you can move the 2 to the other side, making it negative, and then you have 4 x minus 3 at this point. We are at liberty to cross multiply, and if we do cross multiply, it's minus 2 into x minus 3, which equals 4, and this means we have minus double x plus 6 is 4, which means you have minus 2x is equal to 4 minus 6, which is actually a negative 2 exactly, from which we perform division. And if we divide both sides by negative 2, we're able to get that x is equal to 1. So what is the x-intercept? Right, the x-intercept itself is x equal to 1. If you don't write it as x equal to 1, you can write it as a point where x is 1 and y is 0. So there it is, and that is the result. Okay, right. So this is the x-intercept, and therefore we have answered question 5.2 over there. Right. 5.3, you need to determine the y-intercept of f. How do you find the y-intercept? Okay, to find the y-intercept, you need to let x be equal to 0. Once again, this lesson is being recorded like the one we had in the morning. The recording confirmed that it's in progress, and therefore we're good. Okay, right. So in 5.3, we are solving now this particular question, and we're saying determine the y-intercept of f. The y-intercept of f. Right. So we are finding the y-intercept. What is the y-intercept? So you let x be equal to 0. And that is f of x, which equals 4 divided by x minus 3 plus 2, which means f of 0 is 4 divided by 0 minus 3 plus 2. And if you simplify this, is for that plus 2. And therefore, what is the result here? You take the LCD, the lowest common denominator, which is actually exactly 3. You divide 3 by 3. It is 1 by minus 4 is minus 4 plus 3 divided by 1 is actually 3 by 2, 6. And what is minus 4 plus 6 is 2 out of 3. Okay, Right, we're getting this. Right, so we're getting that y is 2/3. What is the meaning of this? Okay, right, so we can see therefore that our x is equal to 0. We write x first and y is 2/3, and that is the answer is 0 and 2/3. Right, so at this point we have the following. Right, we need to, in 5.4, to sketch the graphs of f and g on the same system of axes. Show clearly all the intercepts of the axis and any asymptotes. Sketch these graphs. How do you sketch them? How do you sketch them? Okay, right, to sketch these graphs is very, very straightforward, but both graphs of f and g on the same system of axes, you need to show clearly all intercepts of the axis and the asymptotes on the graphs, okay? So we're gonna look at 5.4. Right, so 5.4 is very straightforward. How to sketch these graphs? So first things first is to write down the equations of the two functions. So f of x is 4 divided by x minus 3 plus 2, and we have the other function. And the other function is g of x, which is x plus 2. Right, you get the recording to this lesson. Okay, you notify me on WhatsApp if it kicks you out. Okay, if the Zoom kicks you out or suddenly drops you, and you notify me on WhatsApp so that I can accept you back. Okay, because it happens sometimes, and I might not know if you're still there, because it might happen that you're off, you've gone off. Okay, because I can't always sometimes see on my screen here. I'm able to see the things I'm writing. Okay, right. So let's look at the two functions. Right. So here are the graphs here. Right. So these are the graphs. Right here is one vertical line, eons, horizontal axis. And this one is the x-axis, and this is the y-axis. So you have that this is x equals 3. If x equals 3, you have y equals 2. Right, so now we have the vertical asymptote, which is x equals 3, and the horizontal asymptote y equals 2. What is the x-intercept? Y-intercept is 2/3. Y-intercept is 2/3. So 2/3 is like approximately 0.6, 0.67. So you're still with me, right? You're still with me? Okay, thank you. All right. Because sometimes if I hear beep sound, I wonder if you're still there. You might have, this thing might have kicked you out without my knowledge because of network. All right. So now you can see that the y-intercept is at 0.6, 2/3. 0.6 is below 2. The x-intercept we saw that the x-intercept was actually 1, exactly 1. X equal to 1. 1 and 0 is the point. So now it's 1 and 0. So this is a sort of graph you have. And this graph is the rectangular hyperbola, Okay, the rectangular hyperbola, because the number 4 is a positive number, it will have one piece there. It will have one piece there. Okay, this theory, I'm going to emphasize it more, but now listen to that fact. Okay, so there are two kinds of the hyperbola graphs. Right, one part or one hyperbola graph is when you have a divided by x and the a is positive. Or you have that y is a divided by x and the a is negative. So what are the graphs that we get out of this? Positive and negative a's. All right, so here if a is positive, it means therefore your graph is going to be here and there in the first and in the third quadrant. And because this one is the first, the second, the third, and the fourth quadrant. Right, so at this point here, if you have this one, a negative, you'll have in the even numbered quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. So you'd have that in quadrants 2 and 4. You'll have that your graphs are present. So in other words, I've made everything red, but in other words, what you're going to have is one piece is here and one piece is there. Okay, in the first one piece and in the third. Okay. So we have sketched the graph of the function f. The next one to sketch is the graph of the straight line. So the straight line is very, very easy. Now here is how we sketch the straight line graph. Now when x is 0, y becomes 2. When x is 0, y becomes 2. When y is 0, you write like this. You write like this. And then you get minus 2. Okay, so you get minus 2. Okay, you notify me on WhatsApp, it kicks you out, so you have minus 2. Okay, so if it's minus 2, it means, therefore, that this is going to cut at minus 2. So you have this. So this one here is the graph of the function g. Okay, so those are the two graphs. And now we're supposed to sketch these two graphs, the graphs of f and g on the same system of axes. Show clearly all intercepts with the axis and any asymptotes. Here's an intercept with the axis we have shown, an intercept we have shown, another intercept we have shown, an intercept we have shown. Right, we have shown all the intercepts with the axis, but also we actually show any asymptotes. Y of x equals 3 and y equals 2. Those are asymptotes we have shown. Right, next thing, in 5.5, calculate the x coordinates of the points of intersection of f and g for a total of 4 marks. Right, now the points of intersection. The points of intersection. How do you deal with the points of intersection? For the points of intersection, there are a couple of things we do. But for the points of intersection, what we do is we equate the two functions. We make them equal to each other. Right, so you're going to do 5.5. Right, in 5.5, we're going to do the following and equate the two functions. So that would mean that we're going to have that f of x must be equal to g of x. What is f of x? It's 4 all divided by x minus 3 plus 2. What is g of x? Is x plus 2. So now at this point, we can simplify this and write the following. We have this x minus 3 is equal to x plus 2 minus 2, which means 4 divided by x minus 3 is equal to x. Okay, what do we do here? We cross multiply. We cross multiply. So this is out of 1, which means that we have 4 by 1 is equal to x into x minus 3. So this is x squared minus 3x. This is 4. Then this is x squared minus 3x. Okay, x squared minus 3x. We move the 4. We transpose it so that it becomes exactly negative, right? Upon getting to this step, further analysis reveals, therefore, that we can factorize these. The factors of x squared are x, and now we have minus 4 and 1. So which means x is what? X is 4 or x is minus 1. So at this point, we're able to see that we have those two values of x. And now we just need to find the x coordinates of the points of intersection of f and g. And these are the x coordinates. The first one is x equals 4, and the other one is x equal to negative 1. Okay? Right, so we are in business and we're done with this. We're done with this. The next thing is 5.6. If x is less than 3, determine the values of x for which this is the case. So in 5.6, if x is negative, determine the values of x for which this is the case. Right, so let's analyze these together. So we are dealing with 4 over x minus 3 plus 2 is less than x plus 2. What do we do with this? What is the meaning of this? Well, it means this is the function f of x, and so this one, the x plus 2, is the function g of x. What is the meaning of all this? It means that the function f is less than g of x. If x is less than g of x, what does it mean? Let's look at the graphs. So in other words, f of x is below f of x is below g of x. Okay, so we're going to look at the graphs now and analyze this together. F of x is below g of x. So where is f below g of x? Okay, f is the purple one, the hyperbola graph, the rectangular hyperbola. So it is below g. Now here it is below here. It is below here. It is below there. It is below there. But also it is below here. It is below there. It is below. Right, so what values of x are these? Right, so we know the points of intersection. What are the points of intersection? So we saw the points of intersection at x equal to minus 1. And also x equals 4. So x equals minus 1, x equals 4. So what is this now? What is all this? We analyze it together. Okay, what analyze it together? What's the meaning of this? We're saying we have x equal minus 1, and that is what sits here. Right, so we need to describe the answer. For what values of x is this the case? We can see that immediately at this point, look at this carefully. Look at this carefully. So it's when x is bigger than minus 1. So we start from minus 1. From minus 1, we go on. And also now you can see that up to, for instance, 3, right? So up to 3, up to here, this is 3. So it will go up to here. It is actually below, okay? Right. Obviously, they said if x is less than 3, so we must only take this part of the graph. But I must indicate that we could also take the part of the graph from 4 upwards. For instance, you can see that when x is bigger than 4, for example, there the function f is below g, but the examiner wanted only this solution where -1 is less than x less than 3, so which means that in 5.6, what is the answer? The answer would be exactly this one. It would be -1 is less than x less than 3. Now we continue and we look at 5.7. The line y equals x minus 1 cuts the function f at the point P with coordinates 1 and 0 and Q. Write down the coordinates of Q for 3 marks. What is this? What is this? What is this? Okay, the line y equals x minus 1 cuts f at P with coordinates that and Q. Write down the coordinates of Q. Right, so if this line in 5.7, the line has the equation y equals x minus 1. And this line cuts the function f at the point P and Q. Write down the coordinate of Q. So which means y equals x plus c. So which means at this point, what do we do? What do we do? I want you to realize that we have the graph that is the graph that we drew. We have the asymptotes. We have this situation. Now let's pay particular attention to this. Now, the asymptotes are x equals 3 and y equals 2 is the horizontal asymptote. Okay, we're looking at the functions here. And now they have a point of intersection in these asymptotes where x is 3 and y is 2. They intersect at 3, 2. They intersect at 3, 2. Okay, if they intersect at 3, 2, it would mean, therefore, that at this point, you need to note that x is that and y is that. So y is 2 and x is 3. Okay, which means c is -1. So which means this line here would have x plus c. C is -1. So this one is an axis of symmetry. Is an axis of symmetry is an axis of symmetry of the function f. Right, so what is the meaning of this? So it means now we need to write down the coordinates of the point Q. if P has the coordinates 1 and 0. Right, so this is what you get. Right, what do we get at the end of this? Right, so it means a couple of things. Right, so it means you can imagine that the point Q can be obtained as a point that satisfies the notion of symmetry. The notion of what? Of symmetry. Right, so this is what I will most certainly say here. So you'd have, therefore, that you can equate this and say the x minus 1 line is equal to the function f. So, which means the x minus 1 line is equal to the function f, which is 4 divided by x minus 3 plus 2. So you have x minus 3 is equal to 4 over x minus 3. Because multiply this, and it becomes that is equal to 4. Which is equal to, okay, let me just expand this. The easiest is to expand this, which is x squared minus 6x plus 9 equals 4, which means that this is x squared minus 6x plus 5 equals 0, which means it's x minus 5, x minus 1, x equals 5, or x equals 1. So at this point, what you're getting is that the line is the equation x minus 1. X minus 1. So at the point that x equals 5, for example, you take 5 minus 1, which is what? Which is exactly 4. What is this? This gives us the coordinates of the point Q. So the coordinates of the point Q will be as follows. When x is 5, y will be 4. When x is 5, y will be 4. I want to mention a couple of things. We have made mention of this line here. It cuts f at the point these. Right, so it is true that when x and y are coordinates of P, you'd have x minus 1, x is 1 minus 1, and 1 minus 1 is 0. So y is 0. So when x is 1, y is 0. Okay. They said to write down the coordinates of Q. They are 5 and 4. So we continue and we move forward. We move forward. We're looking at graphs and functions. The next question on graphs and functions focuses on the kinds of graphs that require or involve what we call the rectangular hyperbola. So how do we therefore deal with these kinds of graphs that pertain the rectangular hyperbola? Right, so we're good and we are gonna involve these. Right, question 6 is next. We are looking at more graphs and functions. 6.1. Right, the diagram below shows the graphs of f and g. Shows the graphs of f and g. Now, graph f cuts the x-axis at a. F, it cuts the x-axis at a. Moreover, in C, f cuts at a and also at c. Here's the graph f. It's a parabola graph. So it cuts the x-axis at 2 points. Note the 2 points. Okay, now the graph, okay, the y-axis at E and it has a turning point at D. Here's the turning point at the point D, which is also called the vertex of the graph. The vertex of the graph. So we continue right now and we analyze this even much more. The graph G cuts the x-axis at A, right? So here is the graph G, it cuts the x-axis at the point A. All right, that is evident, and we can see that very, very clearly. And the y-axis at B, so you can see that graph G cuts the y-axis at the point B. And I can clean the diagram up for us. We're trying to familiarize, to make sure we're better familiarized with these particular questions here. We're better familiarized with these particular questions here. Right, so if they then say write down the equation of the asymptotes of G, write down the equation of the asymptote of G. Okay, the function G is called the exponential function. Right, so the asymptote, the exponential function is only one asymptote, is always the number that's constant, and therefore the number that's constant is given by the y value, which means y equals -4 for the exponential function. And you just note that. Here's the exponential function, and here it is. And then here is the asymptote. And therefore, the asymptote occurs at y equals -4. How do we know this? Because we can see it there on the graph. Write down the coordinates of D. Write down the coordinates of D. Right, D obviously is the turning point. Do you know the turning point is also called the vertex? It's also called the vertex. Now do you see the vertex? It is the vertex of the function f, so we can just write down the equation of the function f, which is f of x equals that x minus 3 you square it plus 25. So which means, therefore, at this point, you pick the x. This one is the x, and this one is the y. So which means at this point, from the general function formula that says x minus p squared plus q, and so you always say the turning point is given by pq. So which means at this point, the turning point is given by 3 and 25. Right, so the coordinates of D, the turning point. So this is the turning point. You don't want to call it the turning point. It is also called the vertex of the parabola function. Next question. Next question. Right, we're looking at 6.3 now. Write down the range of F. Write down the range of F. Right, the range of F. F is the rectangular, it's the parabola. What is the range? The range has to do with the y values. Set of y values. So the set of y values, what are these things? So the y values will start from here for the function g, for the function f, and go down. Let's go straight down. What is the y value? So you need to look at the coordinates of the vertex, and the coordinates of the vertex are as follows. There are 3 eons and 25. 3 and 25. What is this? So in 6.3, now you need to find the range. So the range would be what the y values are. So you start from x and y. So this is x and that is y, but now you're going down. And then y is 25, so but you're going down, so which means the range is going to start from 25 and go down. So you say less than 25 or equal to 25. Equal to 25 at the vertex, because at the vertex you have y equals 25, and then you go down, so y is less or equal to 25. Okay. The next question. Right, we need to we have found the thing the range, and then we're looking at 6.4, the length of EB, the length of EB. Right, where is E? Here is E, and here is B. What is the length of EB? So the length of EB is very, very straightforward. To find the length of EB, you need to find two things. You need to find the y-intercept of this one. And also you need to find the y-intercept here, the y-intercept of the function g and the y-intercept of the function f. So in 6.4, y-intercept, you need to find at E, the y-intercept. What is the point E? The point E is the y-intercept of the function f. Y-intercept means that is where this graph cuts the y-axis. So it is the y-intercept of the function f. How do you get the y-intercept? You let x be 0. So now that would mean x is 0. And if that is true, you'd mean f of x so the y-intercept when x is 0, you substitute, you have 0 minus 3 squared plus 25. So this is minus 9 plus 25, which means f of 0, which means f of 0 is 5 and 4, 16. X is 0 and y is 16. The x-intercept, how do you get the x-intercept? The x-intercept, you need to also let y be 0. Well, the y-intercept, that's what I'm talking about. The y-intercept now of the function, the y-intercept of g. So the y-intercept of g, you let x be 0. So now you consider the function g, we take the exponential function there. So we write g is 2 into 1/2 x plus 1 minus 4, but we substitute by 0. 2 into 1/2, 0 plus 1 minus that. So which means you have 2 into 1/2. 1 minus 4, which is minus 3. So when x is 0, y is minus 3. When x is 0, y is minus 3. So what are all these things here? What are all these? All right, these are what these things are. So it means, anyway, at this point, E, you have 16. And it means that at the point B, you have something else. So EB would be what? So EB would be, okay, so it means that you have the distances. So it's going to be 16 minus into minus 3, which means 16 plus 3, which is 19. So at this point, this one is 16. This one is minus 3. So you add them up, it gives you 19 units. All right, so we're going to look at 6.5, determine the values of x for which f is decreasing. The values of x for which f is decreasing. So now decreasing means that when x increases, the function is decreasing. So look at this. The function is decreasing here, it's going down, but it's increasing there. So the function f is basically decreasing here. And it is increasing there. So if it is decreasing, what are the coordinates of D? We realized that there were 3 and 25 for the turning point or the vertex of the function. So now look at this with me in 6.5. So when x in 6.5, so when is this decreasing? So it is basically decreasing when x is actually bigger than 3. Okay, we say the function is stationary at the vertex, okay, because it is neither increasing nor decreasing. There's a section called calculus and metric, which is going to mention what we call stationary features of a function, what we call stationary points or vertices or turning points of a function. So now the function is said to be stationary at the vertex of the function. Stationary at the vertex of the function. Okay, just note that. The next thing to do is to answer the next question. 6.6, calculate the average gradient between points A and B. Here is A, and here is what? And here is B. I need to find the average gradient between them. Six point six. Calculate the average gradient between the points A and B. Right. So we continue. Okay, we continue. So now 6.6 to find the average gradient. So we know the coordinates of the point A. What are coordinates of the point A? Right, so in the coordinates of the point B. Right, so this one here can be easily seen, and then you need just the 2 points A and B. We need to find the coordinates of A, but the coordinates of A are obvious. What are the coordinates of A? Okay, so right, so now you'd have the point B. And what are the coordinates of the point B? Right, let's just write down the equation of the function. So it is the function g, 2 into 1 half x plus 1. So now we want to find the y-intercept. We have found in particular the y-intercept of g. So how do you find the y-intercept? The answer, we need to find the x-intercept. Okay, we found the y-intercept. Let's just find the x-intercept. So now this means the following. How do you find the x-intercept? To find x-intercept, you let y be 0. So your 0 is 2 into 1 half x plus 1 minus 4, which means that 4 equals 2 into 1 half x plus 1. Divide by 2. Divide by 2, which means 2 is 1 half x plus 1, which means 2 to the 1 is 2 to the minus into x plus 1. Which means 1 is minus into x plus 1. This means a couple of things, but it means that 1 is minus x minus 1, which means that x is equal to minus 2. X is equal to minus 2. So now it means the following. So it means that that is the x-intercept. So the coordinates of A would be x equal to minus 2 and y is 0. Yes, please. All right. X is going to be minus 2 and y is 0. Okay, so we continue. Now the coordinates of this are exactly minus 2 and 0. So we continue. You want to solve this. So the coordinates of B will be the following. The coordinates of B will be the following. The coordinates of B, we found the x-intercept. So now we realize that one. And what was the y-intercept of the function? When we're finding the length of EB in 6.4, we found the y-intercept of G, and we found it to be sitting at exactly 0 and minus 3. So it was sitting at 0 and minus 3. Those are the coordinates of the point B. All right, so what is all this here? What is all this? You have this and this. So we continue like this. We want to now find the average gradient. So we just need to find the coordinates of A and B. The coordinates of A here are -2 and 0, and the coordinates of B are, what are the coordinates of B? 0 and -3. In other words, you have the line segment joining the points A and B. So this line segment has the coordinates of A, -2 and 0 at the endpoint. And this one is the coordinates of B, which are 0 and -3. The gradient of this, which is the average gradient. Call it the average gradient, so let's just call it the average gradient. Average. So the average gradient is change in y, change in x. Y2 minus that, x2 minus that. x1, y1. Okay, so now let's check this. So this is x2, y2. So now we continue with the calculation here. What is y2? Is -3. What is y1? Is 0. What is x2? It is 0. And what is x1? It is -2. So you have this one. Okay, so now we are so good. We are so good. What do we then get out of these here? Okay, so we are in business. So we can see that the average gradient is -3/2. -3/2. And which is what they wanted. So the average gradient is this. -3/2. So we needed the average gradient between the points A and B. So alternatively, I mean, if you are looking for the average gradient, it is this, or you can therefore say the average gradient between the points A and B is lowercase m subscript AB, which is -3/2. All right. Right, so we're good. We continue now and we do more. Right, if you look at the next question in 6.7, graph T is obtained by reflecting G about the x-axis. Graph T is obtained by reflecting G about the x-axis. Write down the range of T. Write down the range of T. Let's look at 6.7. 6.7. Right, in 6.7 now, we are going to reflect G about the x-axis. About the x-axis is going to reflect G. Okay, so where is the x-axis? This is the x-axis, this one here. So when we do the reflection about the x-axis as a line, what happens? What happens? So what happens at this point? is that right? So we analyze these together when we do the reflections in 6.7. Right, first let us write down the function g of x. What is the function g of x? Here. The function g of x is given by twice into 1/2 raised to x plus 1 minus 4. The function t of x, look at what is happening. The graph t is obtained by reflecting g in the x-axis, which means t, therefore, is the same as minus g of x, which means it is minus. What is g of x? Right, so what is this? Now the t, if you reflect in the x-axis, y becomes negative. So which means you have these. So the negative now multiplies through. So it's going to be minus 2 into 1/2 of x plus 1. And you have these. Okay, so we have that. So now, that is 6.7. So what is the range? So the range of the function will be what? Now, this is the function now that you are dealing with, and it has this as or a horizontal asymptote. Y equals 4. So if it is y equals 4 as a horizontal asymptote, it doesn't cut that one. So the graph of that would be that you have this, you have that. Right, so you have that. And then now if you reflect about the x-axis, then you have the points switching. Surely the point A is going to be a fixed point, but this point B is going to be reflected directly same distance away. So that would be when x is 0, y is something. What is y? Obviously, the coordinates of B were obtained before. And what would you get them to be? 0 minus 3, so it will just be 0, 3. You just multiplied it, the y by negative, so that it becomes positive 3. Now, when this is true, you have positive 3 like that. So you have a positive 3 there. And then you have this and you have that. And that will be the asymptote. So that will be the graph of the function t. So it will just do that. This function t is the negative of g. And the graph is like that. So what is the range of these functions? What is the range of these functions here? So the range of the function is going to be, it's going to start, so it's going to be y is just less than 4 because this is y equals 4. Well, it will start from 4 excluding that and then just go down, down, down. So you can say the range is y less than 4, or you can say that y is an element of the interval minus infinity to 4. All right. Now, 6.8, you have that if p of x is f of x plus 2, write down the coordinates of the turning point of p. The coordinates of the turning point of p. So you have 6.8. Right, so in 6.8, you need the coordinates of the turning point of P. So in 6.8, you realize that P of X is the function f plus 2. What is the function f? The function f is the parabola. And then you're adding 2 to it. Well, that means if you add 2 to the function, that means that the only thing that is affected, so this is a vertical displacement of the function, vertical displacement by 2 units upwards. 2 units upwards. Vertical displacement by 2 units upwards. So which means that at the vertex of the function, the D point D had the coordinates 3 and 25. But 2 units upwards would mean that now you are adding, and if you add, it's going to be 25 plus 2 when x is fixed, and that is 27. So what is this? Then the turning point. 6.8, write down the coordinates of the turning point of P, turning point. So the turning coordinates of turning point will be 3 and 25. And 27. 3 and 27. Note that because it's going up by 2 units. Now, in 6.9, you need to determine the value of k for which the straight line this will be a tangent to f. Determine the value of k for which the straight line this will be a tangent to f. Let's look at that one. 6.9. The straight line, determine the equation, the value of k for which a straight line y equals 2x plus k will be a tangent to f. Okay, so now we start by writing the function f, which is minus into x minus 3 all squared plus 25. So it is f of x, which is minus. You square this, which is x squared. X by minus 3 is minus 3x by 2 minus 6x plus 9 plus 25. F of x is minus, so you distribute, which is minus x squared plus 6x minus 9 plus 25. So which means f of x is minus x squared plus 6x plus 16. And so the value of k for which a straight line is a tangent to the graph of f It means that we need to say y equals 2x plus k will be a tangent to f. Well, it means a couple of things, but it actually means that you have minus x squared plus 6x plus 16. So that's minus x squared plus 6x plus 16 is 2x plus k. The tangent is one point of intersection, thus two equal roots. Tangent is one point of intersection, thus two equal roots. So tangent has one point of intersection and thus two equal roots. Okay, so a tangent touches the graph at one point. So in other words, if you have a graph like this, a tangent is normally a straight line that we're referring to here. Here's a straight line, and it touches at one point. So this purple color becomes a tangent. It becomes a tangent. Cool. Which means now you have this delta, which equals b squared minus 4ac. This is called the discriminant of functions. The discriminant will be the same as what? So now you have the b. So at this point, you'll have that a is -1, the b is 4, and c is 16 minus k. B is 4, you square it, 4a is -1, and c is 16 minus k. So, which means this is, you square everything, you square the 4, it becomes 16, and then you distribute -4 minus 1 is 4, which means it is actually plus 64 plus 4k. Anyway, it will be minus 4k. Just watch the signs. It's going to be exactly minus 4k. Never minus 4 minus 1 is plus 4, which gives us 64, but the plus 4 times minus k at the end gives us minus 4k. Just watch the signs. All right, in which case, therefore, this discriminant becomes equal to 0 for equal roots. Equals 0, equals 0. So this is 50. Or you add them up, it becomes 70, 80. Minus 4k equals 0, which means 80 equals 4k, which means k is equal to 80 divided by 4, which is actually 20. Then the value of k for which the straight line will be tangent, the value of k is k equals 20. Okay, we continue with the functions and graphs, but also we tap into something we call financial mathematics. Question 7. So we need to understand mathematics of finance, or what we call financial mathematics. It's the next is the subject of discussion right now. Let's learn and revise financial mathematics. Okay, let's look at 7.1. Calculate the effective interest rate per annum if an investment earns interest at the rate of 11.5% per annum and it is compounded monthly. So, very straightforward question. What is this? So what are we supposed to do? We need to calculate the effective interest rate if it earns an interest rate of that compounded month. So the formula we need to use here, we need to know that we need to calculate the effective interest rate or a rate per annum, or interest rate. So we need to know that 1 plus I, the effective, 1 plus I effective interest is 1 plus I, the nominal rate, divided by M. This is norm, divided by M. You raise it to the power M. 1 plus I effective, 0, 115. You divide by 12. Because it's compounded monthly, and so there are 12 months in a year, and you raise this one to 12. Subtract 1, which means I effective, which is 12, okay, so what is the effective interest rate? It is 12.13%. And so we are learning financial mathematics now. We are dealing with two rates of interest. One is the effective rate of interest, which is the annual one. So in other words, the I is the effective interest rate. So I want to write something here. So if we write I subscript effective like this, we mean the effective interest rate. I nominal, this is the nominal interest, nominal interest rate. So that is 7.1. We've answered that one for just three marks there. Right, do not worry about copying everything. You just need to follow what is question. You're still with me, right? Yes. Okay, thank you. Karabo bought a computer, but when Karabo bought the computer, it was bought for 4,700. The value of the computer depreciated. So this is depreciation, depreciated at the rate of 18% per annum. Associated with these kinds of questions is something we call raw information, which we call data. Karabo bought the computer for that much. So in other words, the P, which is the principal, is 4,000. So the present value at which they bought this, it's that one. So this is the present value. Don't want to call it the present value. We call it the principal amount. The principal amount. So he bought a computer for 4,700, depreciated at a rate of 18% per annum, which means I is 18% per annum. it depreciated at that rate per annum, but using the reducing balance method, okay, this is optometric. You need to learn this optometric. Calculate the book value calculations of the computer 4 years after it was bought. So N equals 4 years. So which means it is depreciation. So use the formula with the minus. So, but it's compound interest. So it is 1 minus I to the power n. So this is, what is the principal amount? The present value at which they bought it right now. When they bought the computer, they bought it at 4,700, which is 1 minus the rate of interest is actually 18%. 18% divide 18 by 100, it becomes 0.18. Then you raise it to the fourth power, and this is what you get. You multiply everything, which is 2124, comma 97. 2124, comma 97. 2124, comma 97. It means now using the reducing balance method, calculate the book value of the computer 4 years after it was bought. Now the computer was bought for a total amount of The computer was bought for a total amount of 4,700 and they now depreciated to 2124.97. Hello and good evening. Yes, how are you? Very well, thanks. Yes, please. Okay, yeah. Yes, I'm here. I'm here. Yes, I'm listening. Yes. Yeah. Yeah. Okay, that's fine. That's fine. That's fine. Okay, yeah. I'm just actually having an online meeting now, but I'm at home. Yeah. Okay. All right. So notify me then. Okay, but the base time will be like half eight. Half eight. All right, that's fine. Yeah. All right, that's okay. All right. All right. Thank you. Goodbye. All right. So continuing with our discussion then there. So in other words, I was saying the computer was bought for 4,700, depreciated to 2124.97. So in other words, the computer depreciated to 2124.97. The computer was too expensive. It was 4,700, but now it just became like 2,124.97. So note that. Okay, so let's see what we can do. Okay, we continue. Right, so let's look at 7.3. Right, Nhlanhla made an initial deposit. Right, so Nhlanhla made an initial deposit of 20,000 into an investment account that paid interest at a rate of 7.2% per annum compounded quarterly. After 2 years, the interest rate changed to 7.8% per annum compounded monthly. 4 years after his initial deposit, Nhlanhla withdrew 2,500 from his investment. So in 7.3.1, we continue like this. Right, so calculate how much Nhlanhla had in his investment account 2 years after the initial deposit was made. Right, let's look at 7.3, then 7.3.1. Right, so in 7.3.1, calculate how much Nhlanhla had in his investment account 2 years after the initial deposit was made. Let's do that one. Right, remember that Nhlanhla made this initial deposit into an investment account. Remember, this is an investment account, so investment account grows. We expect the money to grow, so we have E into 1 plus I to the power n, so which means, therefore, you made a deposit of how much? Of 20,000. So we made a deposit of 20,000, 1 plus the rate of interest was 7.2% compounded quarterly. So you take the 7.2%, you divide it by 100, which becomes 0.072. You divide everything by 4 because it's quarterly. There are 4 quarters in a year. And then you say after 2 years, after 2 years, the rate of interest changed to these compounded monthly. Okay, so in other words, it was after 2 years. So before 2 years, it was by 4, which means A equals. So you multiply everything here, which means it is 3068,12. So that's what we're getting. Right. So at this point, it means we have the rate of interest. Right. So it is exactly this. So now they're saying, calculate how much Nhlanhla had in his investment account 2 years after the initial deposit was made. So Nhlanhla had 23,068 rand and 12 cents. Okay. Now in 7.3.2, how much will the investment be worth 7 years after the initial deposit was made? So let's look at 7.3.2. How much will the investment be worth 7 years after the initial deposit was made? 7 years. How much will this investment be worth 7 years after the initial deposit was made? So we're going to do it that way exactly. So 7.3.2, we continue as follows. We continue as follows. We continue as follows. Right, so we have the appreciation formula, which is for growth. If for investments that increase, so use the formula with a plus. For the reducing balance method, you use the other one with the minus. We saw that one there. For the reducing balance method, we used the formula with the minus for the reducing balance method. The reducing balance method. So with A, therefore, equals P into 1 plus I to the power n. Now, this investment was this one 2 years after. But you see, in 7.3.2, how much will the investment be worth 7 years after the initial deposit was made? Right, after the initial deposit was made, 7 years would be given by this. So we know that after 2 years, it became 23,068,12 after 2 years. And 1 plus after 2 years. Now, after 2 years, the interest rate changed to this compounded monthly. 4 years after his initial deposit, Nhlanhla withdrew that amount of money. 2 years. So I want us to analyze this carefully. Okay, this becomes one tidy, so let me remove some of the ink. Right. So you're going to say, I want us to analyze the statement of the change in the rate, but that after 2 years, the interest rate changed to this one. So which means, therefore, that you have these. The interest rate then changed to 0,0. Okay, it's 7,8%. 7,8%. The 7,8% in the question divided by 100, so it becomes 0,078 after divided by 100. But it is compounded monthly, so you must divide by 12. After 2 years, the interest rate changed to this compounded monthly. 4 years after the initial deposit, Nhlanhla withdrew 2,500 from his investment. Right. So for 2 years, compounded monthly, you're going to have what amount? For 2 years, compounded monthly, use your computer, your calculator. So it's going to be exactly 26,949,12, which means, therefore, you have these 26,949,12. You're going to subtract the withdrawal of 2,500. So there is a withdrawal of 2,500. So the withdrawal of 2,500. So if you this is the amount of money for 2 years, and then 4 years. So the first 2 years. First 2 years it became 23,000, and then now you have the following. Yes, hello. Yeah. Okay. Right. I'm having just an online meeting now, but I'm with you now. Okay. Yes, because that's where I'm going to pick you up. Okay. Okay. Thank you. All right. So then you have 26,949,12. You subtract the withdrawal amount. So that is the withdrawal amount. So now if this one is the withdrawal amount, if you subtract 2,500, you get what? You get 24,000. 449,12. Okay, 24,000. So which means that you have A equals, so it is 2 years from the beginning, another 2 years. 2 years when the interest rate was 7.2%, and then another 2 years when it was 7.8%. And then now we're dealing with a total of 7 years, which means for 3 years, the interest rate became what? Okay, obviously it became 7.8%. Still, because for 4 years after the initial deposit, Nhlanhla withdrew these, but after 2 years, the interest rate changed to 7.8% monthly. So we continue. So now you therefore have this is P into 1 plus I to the power n. So now this amount after the withdrawal, after Ntlantla withdrew 2,500, he was left with 24,449 and 12 cents. And then, but the interest rate was exactly 0,078 divided by 12. And then you have by 12, which means now when you multiply everything, it is 30,871,61. Which means, therefore, that this interest for 7 years, 2 plus 2 plus 3, so you have 2 plus 2 plus 3 years, is 4 plus 3 years, which is 7 years. So it means, therefore, 7 years. So which means for 7 years, the amount is going to be exactly 30,000 in that. 30,000 in that. So because the question was how much will the investment be worth 7 years after the initial deposit was made? So 7 years after the initial deposit was made, the investment will be worth 30,871 Rand and 61 cents. The next thing is about probability calculations. Let's enjoy some probability calculations. So we're going to be looking at question 8 about probability. Okay, probability. Question 8. Open 1. A bag contains the following. A bag contains red balls, green balls, and an unknown number of yellow balls. The probability of randomly choosing a green ball from the bag is 25%. So in 8.1, show that there are 32 balls in the bag, just for 1 mark. Let's just show that one. We know that the probability of selecting a green, the probability of randomly choosing a green ball from the bag is 25%, so it's 0.25. The probability of selecting a green ball from the bag is 25%, which is 0.25. So you let X be the number or you let X be the total number. Let X be the total number of balls. Which means the probability of selecting a green ball is what? So the probability of selecting a green ball is going to be the same as, right. Now the bag contains 6 red balls and 8 green balls. So, and an unknown number of the yellow balls. So the probability of the green ball, let X be the number of balls, total number of the balls, so which means that you know that you're dealing with 8 green, and therefore the total number of the balls is X, and the probability is 1/4. 25% is 1/4. This. So if you multiply this and you perform cross multiplication, you can cross multiply this, which means you have 8/4. Because multiply, it becomes 8 by 4 is equal to x, which means x is equal to 32, which means the number of the balls is 32 because they show that there are 32 balls in the bag. So obviously, total number of the balls is 32. Okay, we'll look at the next question, 8.2. 8.2. A ball is drawn from the bag. The color is recorded and is not returned to the bag. Thereafter, another ball is drawn from the bag. Second time, the color is recorded and it is also not returned to the bag. So these are the withdrawals from the bag, removals from the bag, and they're not returned to the bag afterwards. They're not returned to the bag afterwards. Draw a tree diagram to represent all the possible ways in which the two balls could have been drawn from the bag. Show the probabilities associated with each branch, as well as the outcomes. Right, so let's do this one. We need to draw a tree diagram. So to draw a tree diagram in 8.2, we start as follows. Draw a tree diagram to represent all possible ways in which the two balls could have been drawn from the bag. Show up the probability associated with each branch as well as the outcomes. Right, so we're going to start as follows and say, the probability of the red, the green, or the yellow. We have 32 balls altogether inside the bag, and therefore, how many red are there? There are 6 red. So it's 6 out of 32. How many green? There are 8 green. 8 out of 32. How many yellow? Because there are 32, 6 plus 8 is 14. You need 18 to make them 32. So which means they are 18 yellow out of the 32. That is the probability. Right, so we continue with the probability estimations. The we still have, if we continue drawing for the second time, we have red, green, yellow, red, green, yellow, red, green, yellow. What is the red? Right, remember that these red were drawn and these withdrawals, they removed from the back, but they did not return these. So in other words, obviously you can have that you will have the following. So you'll have possibly 5 out of 31, there were 32, but in the first withdrawal, no, it was not returned. So you're dealing with 31 now. And with the green, you have potentially 8 out of the total, which is now 31. And the yellow, you'd have 18 out of 31. Right, obviously we're looking at the possibility that here they remove a red ball. In the second withdrawal, they withdraw a red ball, that is the chance. But if they do not take a red ball out and you still have 31, you'd have that they can take 7 out of 31, which means it is 7 of the green out of 31. Or you have a total of 18 out of 31. Right, the red balls here would be the same as what? What are the red balls? Right, so now you continue. The red balls here, you would have 6 out of 31. And then here you would have 8 out of 31. And the yellow balls would therefore now be 17 out of 31 if they pick a yellow ball from this. So, which means therefore the probabilities here would be, the possible outcomes would be red, red, or you can do red, green, okay? Or you can do red, yellow, right? Here you can do green, red. Here you can do GG, green, green. These are the possible outcomes. Or you can do green, yellow. Here you can do yellow, yellow, red. Here you can do yellow, green. Here you can do yellow, yellow, like this. Okay. Right, so we good. Okay, continue. Now, if you look at that is 8.2 we're dealing with. Right, in 8.3, calculate the probability that the two balls drawn from the bag will have the same color. The probability that the two balls drawn from the bag will have the same color. So we look at 8.3 now. That would mean the probability of the balls having the same color, it will be the probability of green, green, or the probability of drawing red, red, or, so you add when you say or, the probability of drawing yellow, then yellow. So what is the probability of green, green? Right, the probability of green, green would be, here is green, the probability of green is 8 out of 32. Okay, so after at this point, you look green, green. 8 out of 32, and then you have 7 out of 31. That is green, green. So it's 8 out of 32, then 7 out of 31. So you'd have 8 out of 32, and then you have 7 out of 31 plus. The probability of red, red. Red, red is this one. So red is 6 out of 32, but also it goes with 5 out of 31. So you'd have 6 here out of 32, 5 out of 31. Yellow, yellow would be 18 out of 32, 17 out of 31. 18 out of 32. 7 out of 31. Use a calculator for this, it becomes 49 out of 124. The calculated probability that the two balls drawn from the bag will have the same color, which is exactly 49 out of 124. Okay, we're doing more probability calculations. So let's do more probability calculations, and you can expect this kind of a question to feature in your end of the exam. More probabilities, and now we are looking at probability calculations and functions with graphs. Now, in 9.1, on a flight, passengers could choose between vegetarian snack and chicken snack. So, the people on the flight, when they're busy flying from one country to another, one region to another, there's a vegetarian snack possibly, and there's some chicken snack for them to enjoy on the flight. The snacks selected by the passengers were recorded, and the results are shown in the table below. Okay, so these results are shown in the table below. We have a snack. Now, the vegetarian male is 12, female is 20. The total is the two just at 12 and 20. The chicken male are 55, which shows that, which shows chicken, but a female chose chicken 63, and the total is 118. Now the total males is 67, total females is 83, and you have the total states. So you have these wonderful two-way tables there. Okay, in statistics. Probability calculations: was the choice of snack on this flight independent of the gender? Motivate your answer with the necessary calculations. Was it independent or not? Right, so we're going to look at this one. So which means that we're going to look at the probability of, okay, we're looking at independence, which means we're going to look at the probability of male or female. Right, or now, but obviously the choice of the snack. So now the probability of choosing vegetarian times the probability of choosing the chicken snack. Right, the chicken snack. So now the probability of choosing vegetarian or the probability of choosing or the probability of male, was the choice of the snack on the flight independent of the gender? Choice of the snack. So suppose somebody chooses vegetarian and the male. So that would be 32 out of, right, so vegetarian is 32 out of the total 150, multiplied by the probability of the male is 67 out of the total 150, and therefore it's 0.095. The probability of choosing vegetarian and being male, probability of choosing vegetarian and being male, and so what is the probability of choosing vegetarian and being male simultaneously? Let's look at that one. All right, so suppose somebody chooses the vegetarian snack. They don't want chicken, they don't want meat, but they want only the vegetarian version. So the vegetarian and male, probability of that would be what? Okay, now you go to the table and now you look at the vegetarian and male, and it's 12. So it's 12 out of 150. And so this is 0.08. We can see clearly that the probability of choosing vegetarian and male is not equal to the probability of choosing vegetarian and the probability of male. The events are not independent. That is the conclusion. The events are not independent. Okay, independent events will be even come at matrix or are not independent. So just note that independent events would mean that the two, the probability here holds true, and these are equal to each other. These are equal to each other. That's 9.1. 9.2. For any two events A and B, it is given that the probability of A and B is 0.12. The probability of A or B is 0.83. The probability of B is 4 times the probability of A. Are events A and B mutually exclusive? Justify your answer. Let's look at this one. Mutually exclusive events. So we're looking at 9.2, then look at 9.2.1. Okay. In 9.2.1, are events A and B mutually exclusive? Justify your answer. So in 9.2.1, we're going to look at the probability of A and B. What is the probability of A and B? It is 0.12. It is not 0. So now, if they are mutually exclusive, it was supposed to be 0, but it is not 0. So the conclusion, because it's not zero, it means that the events are not mutually exclusive. Not mutually what? Exclusive. 9.2.2. Calculate the probability of B. Right, so the probability of B would be as follows. Which means the probability of A or B is the probability of A plus the probability of B minus the probability of A. Okay, I'm running out of space here. Let me write below. So if you have the probability of 9.2.2 of A or B, probability of A plus the probability of B minus the probability of A and B. Right, so what is the probability of A or B? 0.83, so you put 0.83, they've given it to us. 0.83. What is the probability of A? Okay, that one you leave it like that. The probability of B is 4 times the probability of A. So it's given that way, it's 4 times the probability of A. Now the probability of A and B. Probability of A and B is 0.12. So which means that now if you have the probability of A plus the probability of B, it is 5 times the probability of A. And then now you have 0.83, you add 0.12, and this is, it means that the probability of A, you divide by 5, 0.19. This means the probability of B is 4 into 0.19. Well, you see, this is true because you've been told that the probability of A, excuse me, the probability of B is 4 times the probability of A. So which means 4 times the probability of A is 4 times 0.19, which is 0.76. Okay, they said we need to calculate the probability of B, and we've just done the probability of B in question 9.2. 9.2.2. And then now in 9.2.3, want the probability of not A. What is the probability of not A? So we're looking at 9.2.3. So which means at this point, the probability of not A is equal to 1 minus the probability of A. That is the formula. The probability of not A is 1 minus the probability of A. So which means 1 minus, what is the probability of A? Is 0.19, which is 1 minus that, which is 0.81. And that's the answer. Okay, we're done with the exam, and then we get 150 marks. Right, we started and went through the questions. We started about 8:31. So my aim is to just finish immediately after. So we must finish at 20:31 approximately, just slightly after. So I will do some practice. Okay, we're looking at these now. It's in this idea of sequences that also appear in the exam. But now we have, for example, the idea of what we call quadratic sequences. Let's look at the quadratic sequences. Question 4. The quadratic number pattern, that one, in 4.1. So you have 4p 11q22. quadratic number pattern, this one has a constant second difference of 1. Okay, so let's look at this one. Is question 4. Question 4 with a specific focus on that. So we're going to find the differences here. Here you're going to say p minus 4. Here you're going to say 11 minus p. Here you're going to say q minus 11. And here you're going to say 22 minus q. Okay, so continue with this. Right, so what do we achieve out of these things here? So now we get further differences because we must continue to the constant second difference. Right, so we have been told that this constant second difference is 1. So if we subtract these here, it becomes 11 minus p minus, so 11 minus p, but you subtract p minus 4. This is exactly the same as what? It's the same as 15 minus 2p. Here you continue, it becomes 33 minus 2q in the same way. And so in the same way, this one becomes what? It becomes exactly q plus p minus 22. In the 4, we have 15. Right, so we are told that 15 minus 2p, the second common difference is 1. It means that all these things are 1 here. This one is 1, this one is 1, and this one is 1 because these are the second differences. Right, so these are the first differences, and therefore these become the second differences. Goodness me, this is 1, and that means that we have 15 minus 1, which is 2p, which means that we have 14 equals 2p. We divide through by 2, which means 7 equals p. Right, so we have got that 7 equals p. We just need to find q. Right, to find q, we can take any of the equations that is q in it. We can take this one. For using that one, so we're going to proceed using 33 minus 2q is 1, which means that is 2q here. Minus 2q is 1, which means 2q is 32. You divide by 2, which means 16 is q. Right, they said show that q is 16, and we've just shown exactly that. We continue with our discussion right now, and we're going to do open 2. Determine the general term Tn of the quadratic pattern. The general term, so we can easily be able to find the general term there. How do we find the general term in 4.2? Right, so we have 2a equals 1 because the second differences are constant and 1, and which means therefore that we divide by 2 and a is 1/2. The next thing is to always say 3a plus b, okay? So 3a plus b is p minus 4. 3a plus b is actually p minus 4. What is p? It's 7 minus 4 because p is 7. And then we have 3a plus b, which means 3a plus b is 3. Okay, if a is 1/2, then it means if that plus b equals that, which means it is 3 minus 3 and 1/2. And all right, so we have that. So if you have 3 minus this one here is going to be 3 over 2. So we have that. So you continue. Right, so there is always the A plus B plus C part. A plus B plus C is equal to the first one in the sequence. So A plus B plus C is equal to the first one in the original sequence. In this case, it's equal to 4. So you're going to say A plus B plus C is 4. What is A? Is 1/2. What is B? Is 3/2. What is C? Is what we're looking for. What is 1/2 plus 3/2? Is exactly 2 plus C equals 4, which means C is 4 minus 2, which is 2. Which means Tn is An squared. Okay, Tn is An squared plus Bn plus C. So which means Tn is A. What is A? A is 1/2. B is 3/2n plus C is 2. Half n squared plus 3/2n plus 2. Determine the general term Tn of the quadratic pattern. Determine the value of n if Tn is 232, right? So we continue to look at 4.3. Now we are saying we have that Tn is 232, which means half n squared plus 3/2n plus 2 equals 232, which means that you have half n squared plus 3/2n minus 230 equals 0. You multiply it through by 2, which means n squared plus 3n minus 460. You multiply it through by 2, and you get equals 0. You can easily get the factors of this. The factors of n squared are n, and the factors of 4 minus 460 that give 3 are 23 and 20, which means n is not minus 23, or n is equal to what? N is equal to 20. So we have this. So n equals 20. N is not equal to minus 3, minus 23, excuse me. But n is 20. So they said determine the value of n, so the value of n is that one there. All right. Right, so we're looking at 4.4 right now. If the sum of two consecutive terms in the pattern is 1, 2, 2, 7, calculate the difference between these two terms. So let's look at 4.4. Right, in 4.4, we have the following. Right, so the sum of the consecutive terms. So that means that Tn plus 1, this sum is 1, 2, 2, 7. What is Tn? Tn is half n squared plus 3/2n plus 2 plus, you add this one, which is half into n plus 1 squared plus 3/2n plus 1. Okay. Plus 2, and this result is 1, 2, 2, 7. So now you multiply everything here. So this is exactly half n squared plus 3/2n plus 2 plus you square the brackets, n plus 1 whole squared, which means it is n squared plus 2n plus 1 plus 3 over 2 plus 2 equals 1227, which is half n squared plus 3 over 2 plus half n squared plus 1/2 . So if you deal with all this, you add the like terms, it becomes n squared plus 4n plus 6, and the result is 1227. And this is exactly n squared plus 4n minus 1221 equals 0. N plus 37 n minus 33. Does that affect us? Here, the number of terms cannot be negative, so n cannot be negative 37, but n is 33 there. Okay, if the sum of the two consecutive terms is this one, so we added the terms and we got the sum of this, calculate the difference between these two consecutive terms. So which means that it is term number, this happens when n equals 33. So what is the difference between these terms? So the difference is when you subtract, you minus. When you minus, it means is t of 34 minus t of 33. T 34 is 1/2. 34 squared plus 3 over 2. 34 plus 2. That shouldn't be the formula, but you subtract 1/2 of 33. 33. So if you do this, this is 631 minus 596. And the result is that you have 35. Which means t of 34, t of 33. Right, so the difference between the terms is 35. Right, we've just done one question on the quadratic number patterns. This is a quadratic number pattern. All right, we've just solved the full question. And after having solved the full question, we're excited about it. And looking at the time, and the time is exactly 8:41 on the dot. And that means that we have gone up to 8:41 p.m. And therefore we good, or up to 20:41. Okay, so this is the time at which you need to take a break and say, I need to have a good evening. I'm going to send this link in at some point. Give me like 1 hour to send the video. I'm going to send you the recording to this. Okay, when I send you the recording, you take the recording, you watch it, you write down notes. You need to separate a book, not your school book, but a book that you're going to use to practice the kind of stuff we're doing. All right, so you take the book. In the book, you write the things properly. You note everything down, and you write the questions and the answers, the questions and the answers, the questions and the answers, and then you study everything. And then after that, you write the question on a piece of paper in your practice book, and then you close the answers and see if you can be able to get the same answer we got together. If not, check again until you're able to get all the answers we actually have been able to get. That is how you're going to practice the questions we did. And then I'm going to send you additional questions, but first I want you to repeat these ones by practicing them, making sure you can do the questions I've done before I give you more, because it doesn't help to give you like thousands of questions, because if you're at school, you get thousands of questions, but I want you to be able to learn these questions I've given to you now. All right. Any questions? Any questions? Are you still with me? Are you still with me? Hello, hello. Okay, you muted.
Oh, I can hear you.
All right. You can hear me, right?
Mm-hmm.
All right, thanks a lot. It's the end of our discussion now. It's like 8:44. The time now is 20:44. And it's we started at 18:31. Okay, sorry, it's the end of our discussion. Thank you so much for joining us. Please practice these questions and make sure that you can do them. I want you to repeat these questions like I wouldn't like to give you like billions of questions at times, so I'm going to give you like lots of questions additionally. But first, I want you to like take a book, a separate book. You write these questions down and question, answer, question, answer, question, answer. After that, you do what? You practice them and you close the answers and see if you write the question in another book and you see if you can be able to get to the same answers you got to. Okay.
Okay.
Right. So thanks a lot. I will need time this week. So you allocate like tomorrow or Tuesday. Let me know which day fits you. Okay, because I want us to do more. Either tomorrow after school from 8 p.m. to 10. I wish. So I'm thinking of that one. So let me know if between 8 and 10 tomorrow you're occupied. Okay.
Mm-hmm.
All right.
Thank
Okay,
you.
so thanks. So thanks a lot. Have a good evening. We'll talk on WhatsApp. Okay.
Thank you.
Thank you and goodbye.
Bye.
Goodbye.